Right. Now we're live. Welcome everybody here at News, and welcome everybody watching us on the stream. It's quite surprising how bright it is because we haven't had a meetup for a while, and the last one we had, it was at the same time, but it was completely dark. So this is new. But you didn't come to listen to me. You came to listen to Petr, Honza, and Milan, who have talks about tooling around your code, and I just want to give kudos to Honza for coming up with the Coding the Code name of the event. So thank you for that. And Petr, the floor is yours.
Okay, can you hear me? Perfect. So one more time, welcome everyone. Have you ever found yourself staring at thousands of lines of code, wondering how do you update it to a latest version of a library or framework? Or maybe you have been tasked with refactoring a large code base to follow some new best practice. If you have, you know that it can be a huge manual task that can take hours, days, or even weeks to complete. But what if I told you there is a way how to automate most of that work and make it a breeze? Welcome to the world of code modes. My name is Petr Bambušek, and I work here at Muse as a front-end staff engineer. And today I would like to tell you about what code modes are, how they work, how you can write them, and show you some real-world examples how we use them to help us with refactoring our code base. So let's get started. As I mentioned, the challenge is with large scale. If you have a small project and a couple of files, couple of lines of code, you can probably do it on your own, manually, no problem. But in Muse, we have around 10,000 files, 400,000 lines of code, and we have a code base running for more than 10 years now. Imagine doing that manually. So what are your options to refactor? You obviously can do find and replace, but as Sean Bean tells us, it's not that easy with the, let's say, bigger problems, bigger patterns. You might probably try to do regex, try to write some complicated regex, but even those, they have all limitations. And that's exactly where code modes can shine. Code modes stands for code modification. And with the little quote, it's an automated tool for large-scale systematic change with the minimal human intervention. What does that mean? In a simple words, usually code mode is a script that you can execute on the code base. It will do the transformation, it will create some task, some change, and then you can review those changes and verify that they have been done correctly. So it's the script usually runs in a couple of seconds or even minutes, but not days. And most of the work is automated. You just verify that it's been done correctly. And how do code modes do it? Well, they use something that's called abstract syntax tree transformations. And now you might be wondering, what the hell is abstract syntax tree? So I hope that you will bear with me for a little bit of theory going into what abstract syntax tree is. So let's start with 4 key steps of code mode is. Don't be confused as the math lady. There's just 4 steps. It's simple. It's parsing, traversing, transformation, and generation. So let's decipher it step by step. First step is parsing, and that means that we take a source code that we want to change, and we transform it to abstract syntax tree, or shortly AST. So let's imagine that we have a simple function called sum. It just sums those 2 numbers, and we would like to run it we parse it into abstract syntax tree, and we end up with something similar to what you see on the right side. And that's just like kind of like pseudo abstract syntax tree, but it can show what the abstract syntax tree can look like. And if we like look into detail what it means, abstract syntax tree, well, it's a tree. Tree is a common data structure. There are many ways how to use trees in computer science. For one example, they are used in databases for data storage. They are used in many the most effective search algorithms. So tree is a common data structure. In our case, we have abstract syntax tree that represents the syntax of the source code. You can see that there we have nodes, and each of those nodes has a type, and it's somewhat resemble the source code. Let's move to the next step, a traverser. What we want to do with the tree is visit every node in a tree. Essentially, if we have the source code on the left side, and we start in the tree at the top node, we want to well, let me first say there are many ways how to traverse the tree, obviously, because they are used in many different algorithms. What we want to do is to read the tree in the same way as we would read the source code. So how to achieve that? Well, we start from the top and we go always left to right, and then we go as deep as possible in that branch. So in this case, we go through name to sum, then we start to return back to parameters, and you can see that it follows the code as it would be written in some file. And then this way we can run through the whole tree and end up at the end of our code. So this is way how we can traverse the tree and use it for the next step. That's the transformation. During the traversal through that tree, we can change the nodes that we care about. Yeah, every tree has every node has some type, and we can define some transformations. Those transformations are usually just functions that define what type of node they want to match, how they want to change it. So let's say that we have a parameters transformation. If you remember the function, let's say we want to change the function from not taking just two parameters, a and b, but we want to change it so that it takes a array of numbers, and so that it's more variadic, right? So we have the transformation. We are traversing the tree, and we suddenly stop at the node parameters. We ask, is it the parameters? And it is. So we do the transformation, and we change the tree. And then we just continue with the traversal, and the tree looks differently now, but it doesn't matter. We continue with that. As usual, we ask, is the numbers a parameters type? And it is not. So we don't change it, and we continue. Of course, there can be multiple different transformations during that traversal, and not just one. And we can change the tree with multiple transformations. And the last step, we have a generation, and that's just an inverse operation from the first step. We take the AST, and we have slightly different one, and we turn it back into the source code. And obviously, I cheat a little bit in the tree. I'm saving the space. The tree would probably look a little bit complex, but you get the idea. We have now a different tree, and we turn it back into the code, and we get the different code. And that's, in a short, how the code mode works. So it's 4 key steps. You start with the source code. You take a parser. The parser is usually something that you get from some tooling library or your language tooling. You turn it into abstract syntax tree. You traverse it and transform it during the traversal, and then you end up with different AST. Then you generate back source code. 2 points to this. Notice I don't talk about any specific language here. It's not limited to JavaScript, TypeScript, or any other languages. It's actually a concept that's behind many different toolings in any language. Yeah, and the abstract syntax trees are not used just for code modes. They are actually used for anything, for many different toolings like compiling and transpiling. Fun fact: you might actually be using this, and you might not even know it, because it's the essential idea behind the Babel. Couple years ago, Babel was more useful than maybe this year's or today, because the tooling or browsers has catch up. But a couple years ago, there was the JavaScript specifications way ahead, and we were writing code that wasn't runnable by browsers. And actually, Babel was the tooling that enables us to do it. Right? We run it through the Babel. Babel runs some transformations on the code and give you a code that's runnable by browsers. So that's enough theory. Let's look into something more practical. And let's write our own code mode. So how do we do it? Well, we'll demonstrate it on a simple code example. Bear with me, I will show you some real-world examples that are more useful than this one. But already we have an example that will help us to demonstrate the power of code mode. So we have this piece of code. It's just two functions, square and cube. And let's say we would like to change the square to use x for variables instead of n. Very contrived example, right? But it already shows you some problems. We have those two functions in the same file. And if we would just run simple find and replace, we would have to deal with the fact that we don't want to change cube. If we would, we could probably write some regex, but it would be very complicated. And that's exactly where code modes shine, because they have the context and they can decide on the fact that, okay, I'm now inside the square function during the tree traversal, so I know that I should be changing the variables. If I'm outside, I'm not changing them. So what will we need? Well, there are plenty of options. When I was actually introducing into Muse, I tried a library called JS CodeShift from Facebook. There might be other options to write it with TypeScript. But in the end, I actually settled on what I already mentioned, a Babel. We already use Babel in our stack, so it was very easy to actually start using it also for code modes. So how do we write a code mode? Anybody? We remember the math lady. She was telling us. It's 4 key steps. It's parsing, traversal, transformation, and generation. So let's check how we do it with Babel step by step. First, parsing and generation, because it will provide us with some nice framing of the code mode, as they are inverse operations. We have some code, for simplicity, just in string. We run parse on that code from Babel, we get AST. Then we can run generate on the AST, and we get the output. And during that output, we will also have the code, and it will be unchanged until so far. Then we add the second step. That's the traversal. We have also a function for that from Babel. It's called traverse. It takes the AST, and as a second argument, it takes your transformations. Now, how do we actually know what the transformation will look like? We need to match the types, right, of the AST. So for that, we have an amazing tool. It's called astexplorer.net. And you can actually use it for many different languages and with different toolings and libraries. And I assume that we will also hear about it in other talks, maybe. So in my case, I pasted the code snippet that we want to change. And if you notice, I had actually cursor on the n variable, and on the right, it highlighted what type is it. It's an identifier, and it's not name n. So we now know how to write the code mode. We will match all identifiers in the function that's called square, and if we match that, we change it to x. So let's write our transformation. We have the traverse function. We match all the identifiers in a Babel. You name the function as the type you want to match. Then we just match nodes identifiers that are named n. And if we match that, we then look for parents of that identifier. If it's a function declaration and if it's named square, then we had the match and we just change it to x. And that's it. That's the whole thing. So it's that simple. So now let me try to switch to a short demo. Hope you will see it. Maybe I can do it a little smaller. So I have the pretty much the example as you saw it. There's the code. There is the parsing to AST, traversal. There is the transformation. Then I generate the output back, and I just console log it. So if I run it, it's called, and we can see it, hopefully that it changed the square to x, but it left the cube unchanged. So that's simple, right? But that's just the beginning. We now know how to execute the code mode, how to write it, but we need to have tools how to execute it on the whole code base, because we need a large scale, right? So what do? Well, we first separate our transformation. Since we are working with Babel, well, we will do a Babel plugin. And if you have ever been wondering how Babel plugin look like, they are actually very simple. All they do, or they are exactly just those transformations. So we take the transformation that we write, we wrap it in some function, give it some structure, we export it, and we add some typings from Babel so that it's easier for us to write it, but that's it. Here you have your Babel plugin. It's that simple. So now we have a plugin. How do we execute it? So I was wondering, maybe we could use Babel CLI. Babel CLI is a tool that you can use to execute Babel, but Babel, as we know, is focused on translation of your code so that it's runnable in browsers. It's not exactly a tool for code modes. So is it possible to use Babel CLI to execute plugin as a code mode? It is. I managed to do it, but you can see the command is quite complicated. I need to use some dirty tricks to actually use output directory same as input directory, etc. And it was running, but it has some limitation. First, there's no Prettier included. What Babel outputs is slightly different from what Prettier would output. So if you use, for example, Prettier, you would need to run it again on the code base through Prettier. Maybe not a big limitation, but it's annoying. There are no ways to pass the options. Some of the code modes might actually need some options. There's no way how to do it with Babel CLI. And I guess the most annoying is if the Babel CLI fails on some files during the transformation, instead of just skipping that file and like continuing on the code base, it will just fail completely and stops execution. So Babel CLI is not the best option. How about some specific runner for code modes? There are options. When I was actually working, like introducing into the Muse, I used a library called Code Mode CLI. It's way easier to execute it. You can use it with Prettier included, and you can pass the options as a JSON object. However, the Prettier is only in the older major version. In the new major version, it was removed. I don't know exactly why. So that's annoying, but you can probably stick to the older version. But there's another limitation. For some reason, it doesn't work on Windows. And I guess the issue is that it fails to discover Windows paths. So still not that useful. So at that point, I was thinking, how about actually writing my own runner? How hard would it be? And it's actually not that complicated, right? Like we already know how to execute the Babel plugin or how to execute the transformation. We can include Prettier because it has some API also. And we just need to discover all the files in the path and execute in the loop the transformation on them. And so I did it. And I actually created like open source library that you can use if you would like to. It's called Code Mode. It takes the plugin, it takes the options if needed, and it has Prettier included. And I would be happy for any feedback on that. So now we know how to execute it. Oh, and actually I can show you the example. Let me, when I have my mouse, okay. So I have a second folder executing on the code base. I have a plugin here. It's exactly as I described. It's the same thing. It's just a transformation isolated in a function. And I have now like source code. I have the math. It's the same as from the example, but I also have files, additional files here. There's like a file that I don't want to be transformed because it doesn't match any transformation. And I have additional file that has intentional syntax error, so the code mode should fail here. So if I just jump to the directory, then I can run the tool that I was talking about. Just pass the plugin and source. It will run. It will give you some output. You can see 3 found files, 1 changed, 1 error. The error is outputted, but it's ignored. The dimmed file here is not changed, and the one on math is changed. And if we actually change how it looks like, yeah, we got the code mode applied. So this is a way how you can actually run it on the whole code base. So now some real-world examples so that you actually can see where the code mode can be useful. So one example that we did at Muse was getting rid of default exports. If you know what default exports are, usually what we want to do, we want to change them for the named ones. Because in the end, if you actually import the default export, you have to give it some name. So it's annoying if you give it different names in different files, etc. And in most cases, we actually give it the name right in some indexer export file. So why not just use the named ones from the start? But as I mentioned, our code base is quite large. You have thousands of files. Doing this manually is annoying, doesn't give any value. But it's a best practice that we agreed upon. So how do we now change it? Well, that's how we actually started with code modes. So what do we do? Let's say we have this kind of example. We have some object that's exported as default. And what we want to change it is on the right, that we export it directly as the person. So this is the base of the code mode. But when we do this, we also need to change the imports and the exports. And the code mode does it in a single run throughout the whole code base. But does it, just want to mention, it does so statically and dumb. It doesn't remember that it saw some file and changed the export in those. No, it just looks for the patterns and change them. And this way, it's simple. In some cases, you might actually need to fix something manually, but it saves you a lot of manual work. So second thing that we changed was those default exports. They are no more defaults. They are named one. And we also changed the imports so that we don't have default imports, but a named one. So that is very straightforward, but I challenge you to do this with find and replace on your code base. And there are also some way more powerful things you can do with the code modes. One thing is that the code mode has a lot of context. It can tell you in which file it is running. If you have anonymous export, which is possible to do with the default, if you want to change this to the named one, how do you do it? Where do you get the name? Well, we had the context. We know that it's in file name called sum.js. So let's just take the file name and put it into the file. And now we have a named export. So that was for the default export code modes. We also did another one. And this one is actually useful whenever you refactor, let's say, a lot of code base, right? Like from time to time, we need to do some restructuring. Some files are moved around, and then you just need to go and update those imports. Sometimes it can be maybe do automatically, but sometimes you end up with something that you need to fix manually. So one problem with this, if you would try to do it with some find and replace, you might face on the first problem. You need to know that there's a still text key imported, so you don't want to delete the whole line. On the other hand, if you would just be adding date service as like a new import, you might already been something imported, and you need to merge those two. So this is something also that code mode can do quite easily. And the last thing that's actually from my colleague, he's sitting in the audience. He was working on update of a function that we changed from compose function in Lodash to flow function. So if you notice, there's a periodical wage revision function, and it has some update wage and get current wage methods, and those are actually in the opposite order in the Lodash and in the FPTS, and otherwise the signature is the same. So this is also one thing that code mode can quite easily fix for you. So that's for the examples. One note, if you would like to dive deeper into how to do code modes with Babel, there's amazing Babel plugin handbook that has all the details, examples, how to run it, how to work with it, including things like how to write unit tests for the code modes, which is super useful if you are playing with them and debugging them. And some recap, what you have seen today. You have seen the code modes and AST, what it is, how it works. You have seen how to write code mode as a Babel plugin. Remember, there are 4 key steps to code mode. You have seen how to execute it on a code base. You can use the tool I provided. And you have seen some real-world examples how code modes can help you with refactoring. Also default exports, imports refactor, and function migration. And that's it from me. If you would like to get more details, you can follow the QR code. It leads to a repository with the examples that I shown in the talk, and there are also links to slides. If you would like to contact me, you can find me on the LinkedIn or Twitter, or you can also follow news at our blog developers.news.com. And that's it really. So try write something code modes for yourself. Thank you.
Well on time. So when Petr was preparing this talk, we realized that the last time he did a talk was ReactiveConf. If you remember, it's been dead for a couple of years, so that's the last time that Petr gave his talk. And I can never understand how can you work without a mouse, really.
Me neither, but yeah, it's the...
All right, so are there any live questions in the audience? There is one on the Slido. You can all, this is not a Slido QR code, but you can all ask at the Slido. Yes, you can ask there, or you can ask in the microphone, which I would give you. So is there any live question right here? Or let's go into the Slido question. Maybe there will be, let's see. Oh, there are two. So, how do the capabilities of CodeMods compare to WebStorm's inspections and refactoring?
Well, I have no experience with inspections and refactorings in WebStorm, but I've assumed that code mode will be way more powerful. Maybe not. Maybe the web inspections work with AST. I really don't have any experience. Yeah, but the code mode has, well, a capability to do a lot of context-based decision. Like, you know everything about the tree. What I show is like just basic example. You can, like, you know, find some identifier, then navigate back up to the tree, down the tree, you know, decide and do just complete overhaul of the code underneath it. So I think if you want, like, code mode can have way more power than anything else. That's my assumption.
And you don't know what WebStorm does, but you know that code
But
mode is more.
like I assume that's like, you know, some refactoring tool. I don't know.
Okay.
Depends on how it works. Mm-hmm.
Hi. So we've been using code modes for some time, and it's really useful. For example, in pull requests, when you do the same branch like 10 times in a row, right? You can do it. If you would go to WebStorm and refactor it all the time, every time anything changes or you merge master into it, it's really hard. But so this is probably the like biggest improvement in that.
True.
Yeah, thanks for the addition. So, there are more questions. So, love that you mentioned the importance of code mode runners and love pbambusek / code mode. Have you tried using the Intuita VS Code extension as a code mode runner?
No, I haven't, but I will try then, I guess. Thank you for the suggestion.
So your next talk will be how to use VS
Updated.
Code. Yeah. What language is your CodeBoss primary in?
I think it's nowadays almost TypeScript. Like we actually that's actually a follow-up that we did on since we started playing with the code mode, and I didn't mention it because it probably would be for or its own talk, but we used something similar to code modes to actually migrate our code base to a TypeScript. So we actually took 50% of remaining JavaScript and just change it to TypeScript and add, well, we cheated a little bit. We add like any everywhere, right? But it's way easier to migrate, to add, like, fill in some types in some function when you open some file, then change it completely to JavaScript and then fix the errors. Because second thing we did automatically is that everywhere where we actually get an error because of types, we inserted like a test ignore error. So now we have whole code base in TypeScript, thanks to code modes or similar tools. And yeah, that's, I guess, the answer.
And looks like you have a fan because some anonymous love the talk and they will test
Thank
it
you.
right away. And don't forget to follow Peter on Twitter because he knows all his followers by name. So it should we should broaden
I
his.
have like 5 maybe.
Exactly.
I don't really use Twitter that much here, but
It's your mom and your dad and
yeah.
your girlfriend. All right. Any question here in the audience? Maybe a follow up to anything that was mentioned here. If not, it means that Petr explained everything as he wanted to perfectly. He will be available for signing autographs and to discuss more. And now let's have maybe 5-minute break so you can refresh, and we will get back to Honza's talk. All right. Thank you, Petr.
Thank you.
and we have a lift off. So thank you for coming back. Hope you are refreshed a little bit. The real refreshment is coming at about half an hour. So next up, Honza from Superface. And I know he's an API enthusiast. You just returned from London recently, right? Giving a talk. So now we're lucky enough to have a speaker from London in Prague. Floor is yours.
All right. Can I get my slides? Thank you. So hi everyone. I'm Jan. I'm developer advocate at Superface. I'm actually here from Prague. It was just an accident that I met some folks from News in London. But I'm not going to talk about APIs today. I'm going to talk about language tooling. And let me start by asking you a question, like in live audience. Have you built or wanted to build a programming language? Like, raise your hand, like, don't be shy. Yes. Like, okay. A few hands, okay. So, I mean, building a language isn't, like, so hard, right? You just need to have an idea and a drive, and then you will actually build some parser and maybe some runtime and some stuff like that. But really, like, what to make your language actually usable, to make it fun to work with, that's, well, that's a lot of more things. So just think about it, like what makes a good language developer experience? And for you, for my audience right here, like shout at me, like give me a few ideas. Tooling, okay. Can you be more specific? Formatter, thank you. What else? Syntax highlighting, yeah, that was sort of like a hint. Anything else? Linting, thank you. Documentation, very important. Anything else? Unit testing, yeah. Any kind of testing. So I have a few more ideas here. So obviously you need to have some way to execute the code actually. But syntax highlighting, precisely, that's usually where many hobby languages start with the tooling and stop. You might want to have a linter, exactly. Formatter, maybe it would be nice to have some deeper editor integration with code auto-completion, snippets, stuff like that, can be very useful. Maybe some tools for refactoring. If you don't want to write your code mods for every time where you want to, for example, rename a function or something like that, you could build tooling for that. And obviously documentation, tutorials, examples, and also having some support for developers. And maybe one thing which we tend to sort of like miss, but you know, think about like how the compiler or the tooling you are using with your language, how it communicates with you. Like, what are the error messages you are getting? Because it's usually the case that if everything works fine and you like can understand the error, like you don't mind it. But I miss a slide here for some reason. But think about when you, for example, had a. So maybe it's the case that you had some error which isn't so pretty. So if you have worked with PHP, maybe you run into this error, which you definitely remember. And this is just like a stupid syntax error. So there's a lot of stuff. And the idea here is that maybe we should break it down into like a few groups. So first, you want to make your language work. You want to make it usable. And you want to make the experience, the working with the language, delightful. And to make it work, you have the standard stuff. Petr showed you how parsers work. So you will parse your source code into some abstract syntax tree. And then you can do a lot of stuff with it. You can interpret it, transpile it, compile it, whatever is your language. trying to do. But then there is also the stuff about documentation, specification, to make the language actually minimally usable. Like, so anyone else like who didn't write the language itself can actually pick it up and start working with it. So even stuff like syntax highlighting, I think, makes a pretty good basic thing for usability. And finally, to make it delightful. And I would say that's like the broad category, because this tooling, there can be much more stuff, like things like formatting, editors, tooling integration, auto-completing, like I mentioned. So this talk is called Learning About or Exploring Language Tooling the Hard Way. And I wanted to show you how we have explored language tooling at Superface by actually building a custom programming language, which we call Comlink. More specifically, it's a domain-specific language for working with API integrations. But before I will talk about Comlink, I need to introduce Superface, what it is, and what we are trying to do. I will show you Comlink, why we are building it, and how we sort of manage it, how it works, and what we have learned from building custom language. So first, what is Superface? Superface stands for Super Interface, and we have like a few ways to describe it, like unified SDK and infrastructure for autonomous self-integrating applications. Wow, that's a lot of buzzwords. Or maybe try this one, like proxyless client for integrating third-party APIs. Makes more sense? No? Okay, so let me show you this way. This is how we think APIs work, right? So it's machine-to-machine communication, right? So here is how APIs actually work. First, we need someone to publish some API, to build the interface. Then we need someone to document the interface. On the other hand, we need someone to actually read the documentation. And then we need someone else, or maybe the same person, to actually integrate the API. So for machine-to-machine communication, there's a lot of human work. And, well, where we are going with Superface is to basically eliminate all this stuff. So developers, it's not about like taking work from developers. It's more about making developers able to focus on the actual delivering of features rather than like writing glue code for integrations, maintaining, and all that stuff. And how does this actually work, or where we are in this plan? We have this thing called OneSDK, which is integrated in your application. It's a library, standard library you would install, but it's sort of like a universal API client. And when you are writing your application, you can load a profile of things like, I want to send an SMS text message. So the profile will provide you with some stable interface for doing that and calling this functionality from your code. Then at the build time or at runtime, the profile is actually implemented by what we call a map, which is a piece of code, logic, which communicates with the API. So what's interesting here is that the communication here goes straight from your application to the API provider. And since we can update those maps in runtime, we can, for example, if there is an API change on the provider side, we can update it without you changing your application. And you can have even multiple providers fulfilling the same profile, so we can also do API harmonization in your application without any like third-party servers or like bottlenecks on our side. And how it actually looks in practice, let me just quickly show you. So, for example, here with the SMS message example, I get this example code, and whenever I pick some provider, for example, Mesent, or Plivo, Twilio, basically the whole thing which is changing is this part where I specify the provider and the credentials. And we are building more abstractions on top of this SDK. So now, what's the Comlink? The Comlink is actual language we use for building those profiles and those maps. So we have these profiles which specify what we call use cases. So those are some specific ways you want to use those APIs, those third-party providers. And we use them also to generate interfaces, for example, for TypeScript. And we have a map itself, which is integration code, integration logic, to communicate with those APIs. And here is how actually Comlink looks like. So for the profile, you have this use case. You can specify whether it's safe, unsafe, idempotent. It has some inputs. It has some result. And you can specify even like errors or even examples, document the profile, and we can generate nice documentation from that and interface for your language. And the map is actually, it looks like this. So you can see, like, you see it probably for the first time, but you can sort of infer that you are doing some HTTP request. It's a post, it's a JSON, and you will handle some response and do something with the response in the body. But obviously, it doesn't end here. You can do multiple HTTP requests in a single map, which is very useful for API harmonization, because while some providers need only one HTTP call, others need actually 20 of them. And you can even, we have actually embedded JavaScript in there. So you would think that doing API harmonization or like gluing this code is easy, but sometimes you actually need to do something terrible with those data to format them in a proper way. So so we have like an outer declarative shell for Comlink for these maps, and sort of imperative right-hand side operators where you can use like a full JavaScript. And I dug actually through the history of Comlink, and one of the early prototypes, which seem, when you squint, it seems sort of similar, but like early prototypes were written with YAML and TOML, like markup languages, and I'm sort of happy we eventually abandoned this approach. So really, you would think mapping a bunch of HTTP calls shouldn't be so hard, right? But it turns out you sometimes really need some heavy logic to do that. Now, how we make Comlink work? We parse it, obviously, we run it, and then you can use it in your application. So what do I mean by that? We have some source files, Summa for maps or Super for profiles. We run them through parser, and we have AST like Petr showed you. We actually also use AST Explorer to work with that AST. We have like a custom fork with our parser included, so we can actually check how the code in data looks like. Then we run it. I think one of the disadvantages, what we have learned, is that we have coupled the interpreter for Comlink with our SDK. So currently it's not possible to try those maps out without like writing some extra code for with our SDK. You can find like the Comlink interpreter inside of our SDK. And you can even watch it run when you enter some magic environment debug variables. Then it will show you everything. Hey, I'm stepping into this tree, and I'm now doing this. Generates a lot of noise, and it's terrible to debug. Then we use it. We have a CLI tool which can actually compile those ASTs. ASTs are actually used by the SDK in the application, so we are not running like a full parser every time you run your application, which makes the SDK lighter. And we also have the registry where we can publish those profiles and those maps, and the registry actually distributes the AST back to the SDK. Wow, that's a lot of acronyms. So, what we have done to make Comlink usable? Well, we started with specification as a part of documentation. We have a Visual Studio Code extension, and we have a language server. So let's dive in. For formal specification, what I have learned, there is a flavor of Markdown called Spec Markdown, which is designed to write like formal specifications, like for example for languages. So check it out. And you can even check our specification on spec.superface.dev. We have a Visual Studio Code extension, which provides this stuff like autocomplete, snippets, and stuff like that. But maybe more important part here is a language server. Now, just a room check. Like, are you familiar with this language server protocol? Have you heard about it? Few people? Okay. So maybe you should know that, because that's probably what your code editor uses to deliver all those great features like autocomplete, refactoring, and stuff like that. It's actually stuff designed by Microsoft, where they try to solve this problem, where you have, like typically how language integrations and tooling for editors has been done was, okay, so I want to have tooling for Emacs and TypeScript. So I need to build like an integration for each language and for each editor. Now, what language server provides is that the editor integrates with this language server protocol. It can communicate with the language server, and the language server understands a specific language. So you have language servers, well, basically for any given language. And you can include it in your Visual Studio Code extension. I think even IDEA by JetBrains understand it. Like, it's supported nowadays by most major editors. And just like if you are into nitty-gritty details, you can check the official specification. But the funny thing about language server protocol is that it basically mirrors your whole project, and it communicates through JSON RPC with the editor. So so the editor says, "Hey, I have opened this file," and the server says, "Okay, I will open this file," and or for example, editor says, "Okay, so user hovered over this token. What you will do?" And the server responds, "Okay, so for this token, I can provide this more information, things like documentation for imports, or provide some code modifications, refactors, and so on." Yeah. So language server was sort of like a necessary step to make it usable, or enabler to add more parts to this developer experience for Comlink. But what we have made to make Comlink delightful? Well, not much. So there are parts which we are still missing, and there are in some sort of, yeah, we know about it, or it's actually in perpetual beta, like for formatter. We have a formatter in beta version, but it removes code comments, which isn't something you want formatter to do. We are missing stuff precisely like refactoring and autocomplete. We provide only snippets, which aren't sort of like context sensitive. And what we are especially missing, like the language server works, but it's still pretty dumb. It, for example, doesn't, sometimes it gets into some loop or it needs to be restarted. It integrates a linter, but that linter sometimes get very confused about like what's possible and what not. So what we have learned here is that like taking on building like a whole ecosystem for your own language is, you know, like building that 80% stuff is easy, but like those 20% remaining, like to make it actually fast, pretty, usable, delightful, that's the hard part. And one more thing which is missing by default for your new language is support in GitHub and GitLab. Just a side note, it's possible to edit through this project called Linguist, which is actually supported by both GitHub and GitLab. So if you manage to convince maintainers that your language is important enough, maybe you will get a syntax highlighting and analysis for your language in these tools. So about Comlink, what are our next steps? Well, there's a plot twist, because we had this profile, declarative profile, which defines the interface, and we have this map, which provides this logic with embedded JavaScript. And, well, we are getting rid of the maps. Besides, for many other reasons, the tooling we have concluded that isn't sort of worth to invest in, and we are replacing it with JavaScript. But there are very specific reasons why we do that. One thing is that we have a new version of our SDK, which is built with WebAssembly. So our goal is to bring the SDK to like all other languages. We already have prototypes in Python. It has enabled us to bring support for serverless environments like Cloudflare Workers. And actually rebuilding interpreter turned out to be harder than to integrate like existing JavaScript interpreter. One more thing which is becoming more relevant with every day is support by large language models like GPT-4, because, you know, tools like Copilot, and they understand only some languages. So Copilot is actually pretty smart, and it can pick up Comlink even without seeing it anytime before. But it's still like worse than support for JavaScript in these language models. And this is something what we are building on, where we basically want to generate JavaScript based on the API documentation with GPT-4. And obviously tooling, because with JavaScript we get access to all that neat stuff like code mods, ESLint, Babel, maybe we can bundle those maps. So yeah, it made sense for us. So to conclusion, to make some programming language, usually making it work and making it somewhat usable, those are the easy parts. But making it delightful, that's really, really hard to get it right, especially if it's your language and you are like the primary owner of it. So in retrospect, is it worth building a custom language? I would say no. I mean, we wouldn't probably go through this experience again. But I still believe there's a space for novelty developer experience. Like maybe your language doesn't have to be textual. Maybe it can provide something more, like Ballerina here is designed to give you this visual diagram for your code. Or maybe it can be like fully visual programming language like Enso here. Or maybe you are building like a holistic environment for building backends like Dark Language. Dark Language actually is even more interesting because now they've completely got rid of this editor and they are switching to this whole new large language models work. So they are designing a language which will be designed for AI to work with. But also keep in mind that you want to avoid building an accidental language. So I show you this like early prototype of Comlink in Toml, but luckily we have scratched it. But maybe have you heard about this Greenspan's 10th rule? Nope. So it goes like this. Any sufficiently complicated C or Fortran program contains an ad hoc informally specified backridden slow implementation of half of common lists. So it's a bit dated, but it still applies. The idea here is that eventually your application will include its sort of like embedded ad hoc, poorly designed, poorly documented programming language. And yeah, I think like if any one of you dabbled in DevOps tooling like Ansible or Kubernetes, maybe you will recognize this. So here's a red flag. If you are dealing with things like variables or loops inside YAML, maybe you have run into this rule. So that's it for me. Now I will be here to answer questions. Check out Superface AI, and if you would like to contact me, check out this website. Okay, thank you.
Very good. But you can also ask questions. Like it's not just for the audience. I see some stickers. We don't have a stick. Is it? Hello, hello. Yep, yep. I don't have a sticker for you, but I have a keychain that we 3D printed.
Thank you.
So please use
Very
it
nice.
wisely. I think for the future we're planning to have like a more flexible one, so it doesn't scratch your thigh. and I was worried that nobody will name drop ChatGPT, so I'm happy that you did. Did it help you with creating this presentation or the abstract?
I mean, it was like how much? Like half a year since we have. Since I
we
wrote
planned
this
this for I think September last year.
So I think in this case, I actually asked ChatGPT, but I like completely rejected what it proposed. So I'm not in the like. I still think I can do better presentations. Maybe you disagree.
Okay, that's something for conversation. So are there any live questions in the audience right now? Because somehow nobody asked you anything online so far.
So
is
maybe everyone's confused, or maybe I answered any questions.
If I felt right, almost everything you asked, people didn't know. So it looks like you are very much in the geek world. Like
maybe I cranked up geekiness too much. Yeah.
But if there is no question, yep.
So just to recap a bit, Suma and Super, they shared the syntax, or they shared the language, or it was actually there were two different languages. I got a little bit confused in the presentation there.
Oh yeah.
So yeah, I mean like you replaced something with JavaScript, basically the Suma, I guess.
Suma, yeah, exactly.
Yeah, but I was wondering. Okay, so yeah.
Yeah. So there are superficially similar, but fundamentally they are doing different jobs. So I think they are handled actually by the same code base, but we have like different specifications for both, and they I think they also generate like different AST.
Okay, so I think it was a good idea actually.
And I think actually that's like part of the one of the confusions around like whole Comlink, because like every time we need to specify there's a Comlink profile and Comlink map. So yeah.
Thanks a lot. Thank you.
The question was asked by a man wearing an internet on the t-shirt. Looks like we have a fan, Mohab.
Oh, thank you.
Yeah. So please, Mohab, don't forget to follow also Honza. I know he doesn't have too many followers himself. All right.
Why did you originally decide to design your own language instead of using some existing? That's a really good question. And I sort of hoped for this question, which is why I didn't answer it. Okay, so I think the initial idea was that like doing this glue code, this integration code should be like really simple, like, right? Yeah, like with Padme I showed you. you are just doing like a bunch of HTTP calls. Maybe you will massage the data, but there was also this need for the code to be safe. So Comlink was designed to be sort of like a weak language, which can be sort of like statically analyzed, and we could tell, okay, so this isn't doing anything malicious, or okay, this actually, if you run it, it will probably stay in an infinite loop or something like that. So there was this need for safety because we are sandboxing this code, this integration code, which can be also loaded in a runtime, like I showed you. So those were some of the reasons or reasoning behind designing our own language. But yeah, it turns out that like putting everything in WebAssembly and adding like a JavaScript interpreter, we can pretty much control the environment. And if the script goes wild, if it goes sort of rogue, we can just stop it, limit its memory consumption, and so on. Yeah.
Right. So if this didn't spark any more questions, we will be having another short break. Unfortunately, the pizza is not here yet. It will be. There is some last resort snacks. I'll bring some more, so please dive into them. But the pizza is coming. It's not like a clickbait that it's not, and then we'll leave you with empty stomachs. It's coming. And Honza, thank you for your talk. And in 5 minutes, let's get back for Milan's talk. And we are back with the last, but not least, as they say, talk by Milan from Outreach. And I'm happy to see that not so many of you left after you ate pizza. So it's great that you stay for Milan's talk, which will definitely be worth it. So enjoy, Milan.
So hello everyone, I'm Milan, I'm a software engineer at Outreach, and today I'm gonna talk about extending a lint with plugins, in particular ESLint. So, you know, ESLint, I guess that everyone who works on some JavaScript or TypeScript codebase is using ESLint, or if you're not, some other linter on top of other language like Go or whatnot. So, you know, it's a static code analysis tool that is based on like rules. It's the building block that validate our code in many different ways. And like we can extend the linter also in multiple ways. But maybe the question is like, why the hell would you want to extend it, right? I mean, there's a rich core set of rules for both JavaScript and TypeScript. You already have many like plugins for third-party libraries or frameworks for React, for Jest, React testing library, like you name it. Pretty much everyone has it. But you know what the core rules do not really provide is some like your internal coding standards. So you have like many agreements in your organization on how to do stuff, how to organize your code base, you know, how to do stuff, how not to do stuff, and of course you have it documented, you evangelize it, but like, you know, the question is, does it scale? Because all of these are soft blocks. Like you can validate it on the pull request, but you know, you can miss it. You have to do it over and over again. So especially if you are like, I don't know, authoring a library, you want to maybe, even if it's internal library, you want to provide some lint rules with it to like give the consumers some hints on how to use that library. Or if you're working on a large code base, maybe monorepo, which has like 100 of packages, and you have many teams working on the monorepo, and some like framework or vertical team will set some standards that you should like abide to in the monorepo, but then the like code ownership will be, you know, split among the teams, and like the vertical team will not have the capacity to review everything. So it's great that when they can actually enforce the rules via static code analysis. So before we jump to some actual demo of how to write the rules or the plugins, let me quickly go through how we can actually extend ESLint. So one of the, basic stuff is you can do a shareable configuration. So you take a bunch of rules that are available and you pick what makes sense for your org, how the rules should be configured, and you package it into, you know, as some NPM dependency. You'll probably also reuse some existing configs like for prettier, so you don't like, you know, your formatting does not really like fight with the linter and stuff like that. Or you will even use some like, you know, tech company standards like, I don't know, Airbnb or whoever. Now, other extensions that you can do is custom rules. So you have the base set of rules, but you can actually write your own that are really like specific for your use cases or for your code bases. What you can also do is you can write your own parser for any like non-standard JavaScript features. So, you know, if you would, it's maybe more of a niche like use case, but if you would be, you know, extending JavaScript with your some own custom syntax, you can actually write a parser that will translate your code into something that the ESLint will understand, and you can like use it via configuration. Like ESLint uses Esprit by default. Probably one of parsers that everyone uses is TypeScript ESLint parser, which allows the ESLint to understand TypeScript code base. Like another extension point is the processors. So you can actually, this is something a little bit different than a parser. You can create a processor that will take some like non-JavaScript file, for example, like Markdown, and it will like extract some JavaScript or TypeScript code that is contained inside. So in the Markdown, it can be some code sample, or if you're writing some proprietary API language that has JavaScript inside, you can like write your processor that will extract the JavaScript and pass it to the linter. So yeah, one of the prime examples is the ESLint plugin for Markdown. And least but not last is the formatter. So you can actually take the output of the ESLint, like all the violations, what is wrong with your code, and you can transform it into some custom output. So you can like, maybe build some pipeline on top of that where you will feed that output into some more like analysis on, how are your violation increasing, decreasing, or you'll create, I don't know, Jira tickets for your teams automatically to address some lint violation, like you name it, whatever you can imagine. And so a couple of these things, they can be like compiled into a single package, which is called a plugin, which can contain custom rules, configurations, and processors. So before I wrap up with how ESLint works in general, AST, like not gonna go into detail, you've heard it on the previous talks. So yeah, when you put everything together, like ESLint is in the middle. So you have some input, which is some file, that goes into a processor that will like extract the JavaScript code or TypeScript code. It will feed it to parser, which will translate the code into AST, and then ESLint will traverse the AST and will visit your rules, either the predefined one or your custom ones, with every node that you kinda subscribe to. And each of the rule can report some violations, which you can like neatly format and get it on the output. And like many aspects can be controlled by some configuration that you have externally. So now I'm gonna switch to VS Code, and I'll show you some demo on how you can actually implement some of your own lint rules. It's available, it's public. I'm gonna share it probably under some LinkedIn post somewhere for the meetup, so you can take a look at it and go through it later. All right, so VS Code. Can you read it? Is it big enough? Yeah, all right. So I have this repo called ESLint plugin demo, and it's like, it contains, everything together. So like probably ESLint plugin is something that will live in a separate repo in your org, but here for simplicity, I'm just gonna have everything in here. So this is actually my custom ESLint plugin that implements a couple of rules. Not sure I'm gonna go through all of them. Let's see what the time allows. And I also have like ESLint config, which uses the TypeScript parser because all of the code in this repo is TypeScript, besides the ESLint config itself. And it like does not use any of the built-in rules. It's just like my ESLint plugin demo and some recommended configuration that is exposed by my plugin. And here's some configuration with some overrides. Right now, the recommended config has all the rules on, but I'm at the beginning, I'm gonna have them all off. So if I would now like lint the project, yeah, cool, done, no violations. So now let's take a look, at some code. So, super simple function. Test not empty, looks at the string value, test if it's like non-empty or not null, undefined, or empty string, and returns true, false. But maybe for demonstration purposes, you made an agreement in your team that all of these like testing functions should start with the prefix is and not test. I don't know, consistency. So how to actually implement such rule? So it's super simple. So you'll create or you'll define a rule with some metadata that will tell, okay, the type of the rule is some problem, some descriptions, what it does, what's the recommendation setting, documentation, yeah, bunch of metadata, some like some strings that you want to output on the when you have some violation. It can even contain some extra data, and also some like a note if the violation is automatically fixable by the lint rule. And then the most important part, the actual implementation. So you have a create function that receives some context of the file and some rule listener. And in the rule listener, you can specify which nodes of the abstract syntax tree you want to like look at or listen to. So if I would actually take this code and I would go to AST Explorer, which I accidentally closed sometime, and I will do JavaScript with TypeScript ESLint parser. So now I can see that I probably want to look at this node, right? Which is like a identifier of the function declaration. So if I skip back to the rule and open the rule, so we can see that in the rule listener, which is an object, I specify that I want to like subscribe to function declaration. And as the ESLint traverses my AST, whenever it encounters a function declaration node, this function will be invoked. And inside I can do some simple check, okay, if it's like a named function, right? So because I can have some anonymous function that does not have name, and the name starts with a test, I will report a violation. I will use the location of the node. I will use the message ID that I defined previously. I will interpolate the name with the data that I got from the node, and I will also provide a fixer, right? Because this is fixable automatically. So why bother with changing it on your own? So now if I would go to the ESLint RCJS and I would comment this turning off of this rule, and I would actually go back to the console and lint. Okay, now I got errors, right? So I can see, okay, function test not empty cannot be prefixed with test. Use is prefix instead. Simple enough. And if I open the code in the IDE, I can of course also see the violation here, and actually I can just auto-fix it to the new prefix. Yeah. So this was like super simple rule. Now to give you more examples, I'm gonna not go one by one. Also, sorry, I forgot to run my timer. So if I go over time, just let me know, and I will cut it short. So I mean, let's take a look at some other rules, right? So for example, let's take at theme colors only. So imagine you're building some front-end application and you support theming. And to support theming, you don't really want people to use some arbitrary colors somewhere. So you don't really want to see this kind of code, because this will not work. If someone switches the theme, the button will still be red, and I don't know, not some dark color in the dark mode. So if I would now open the rule for that, I can actually just create a rule that will subscribe to string literal, and ESLint will visit this function for every string literal in my code, and I can run some color regex on top of that, and if it matches some color or something that I identify as a color, I can report it as a violation. So if I would go back in here, I would uncomment the rule, and I would go back here, I can see, yeah, please use theme colors only. Of course, in the theme, I will actually want to use the colors, so in here, I'll simply disable the rule for the file. Now, let's see. comments. So comments are great. It's great to document your code, but like this comment, you know, to do, even like this or like this, it's not very helpful. So you might want to set some standards on how like to do in your code should look like, right? So let's paste it into AST again, and let's find the comment. Like, oops, I mean, it's not there. So comments are not part of the AST. So how do you actually lint that? Well, fortunately, we have ways to do that. Let's save this. So if I now open the lint rule for the to-do comment format, actually, you can like subscribe to the program, which is the whole file. So like ESLint will visit your rule once for every file, and you have this like context object passed into the rule implementation, and in here you can get the source code, get all comments. You can, you know, filter to just to-do comments that start with to-do, and you can, you know, enforce some format. So if I would uncomment this rule, and I would go back to the violating file, yeah, I can now see that to-do comments must contain a GitHub user Jira ticket and a summary. So, you know, like some prescribed format. So it makes sure that to-dos are not just left around in your code base unattended for God knows how long. Yeah. So another type of rule I want to show you is a rule that does not actually like checks the code itself or partially. Instead, it kind of like prescribes some package organization. So maybe you want inside your package, you want some layers like utils, services, components, and you want to structure that, and you don't want like stuff to live outside of these folders. So now if I enable this rule by commenting this, and I would, you know, just not new folder, sorry. So I would just create a new file here. I don't know, foo.ts. You can see I already have a valid violation that like files can only live inside some specified folder. But, you know, also maybe in the package itself, you don't want any files here. So if I would add something here, blah, blah, blah. Okay. Does not work. Bummer. So we can debug that later. Oh, okay, I know why. Sorry. So I will also want to enable this rule. So this rule also happens to be configurable. So it has some like, you know, it has some built-in default where you can like just validate that stuff does not live completely outside of the package's structure. But you know, you can also pass it some additional configuration, and you can add some layers configuration. So you can say, oh, okay, so you know, I have these layers, and they have this priority specified by the index, because you don't want, you know, people to implement components in the utils layer, because this can lead to some, you know, nasty circular dependencies that you will have to solve later on. So this lint rule supports this, and it also, you know, once you enable it, it will actually also enforce that in the top level, you can only have the index file that will, you know, maybe re-export some stuff that should be accessible from the outside of the package, but you cannot add other stuff here. And you can have, you know, some helper in the utils, you can have some service that uses the helper from the utils, and you can have some component that uses both service and and helper. But you can no longer do this, right? So you would just go here and you would say, oh, okay, so I want to call some service here. No, you cannot. Like, layer utils cannot import from services. So you can even do stuff like that, because in the context of the rule, if I would quickly look at the package organization rule, in the context you can actually get the path of the file, you can figure out which layer it is in, and then you can look at the imports in that file, and you can like compare the layers, stuff like that. Quite powerful. All right. But you know, as you maybe you have noticed, all of these rules, they are like kind of scoped to that file. They don't really do like any type checking, but we have a TypeScript code base, and maybe we want to enforce some more complex rules that requires to understand like the abstract syntax tree outside of our single module. So you can actually do that. It's a little tricky to find. The documentation is not great, but if you take a look at some TypeScript ESLint rule implementation, you can definitely figure it out. So the first difference is you specify that the rule requires type checking. This is just metadata, so you know it does not really do anything. But you specify, hey, like if you add this rule, you will require type checking, and it will probably make your linting a bit slower. So yeah, and for this I've created, you know, some like a little bit stupid example. Let me show it to you, right? So could not figure out something better, but it will serve the purpose. So I have this file which defines some like, you know, factory methods that create some like transport object. So we have some base class called transport object, and some like flavors AB which extend it, and then some factory method that creates the transport object. And let's say, you know, that like this is a code smell. So you're creating an object from the factory, maybe it's some expensive, you know, routine, and you just like ignore the return value, you don't use it. So, I mean, you cannot validate this just by AST of this file, because you don't have the context, you don't know what the function returns. But you can actually use create the type-aware lint rule. Let me open it up. So rules, type checking. And yeah, you can use the ESLint utils to get the parser service. And from the parser service of the program, you can get the type checker. And then, funnily enough, from the parser service, you will like convert the ESLint tree node to the actual like original node that was parsed by the TypeScript parser. And on this node, you actually have the full AST. You have the full context of your project. So you can now use the checker, and you can say, okay, so you know I'm subscribing to call expression. So here I'll receive some call expression. So I want to get the type that is returned by the expression. I want to iterate the call signatures, because basically this will give me the function that I'm calling. So I want to iterate the call signatures of that function. I want to figure out what it returns. Then I want to check, okay, so is it a class or an interface? And if it is, I want to iterate the base type of that interface. And if I figure out the base type is actually the transport object, and at the same time, it's an expression statement or a unary expression, so like the value is not used, I'm gonna report some violation. You know, you can probably find some, you know, hole in this code. It's probably does not handle like all of the TypeScript magic, like, you know, some unions and transport object being used directly as a return value and whatnot. But like you get the general idea. Like figuring this out takes some time. You have to like understand the AST. You have to play with it a bit. But you know, in the end, you can really like create rich rules with it. So if I would now go, so I have this, right? So if I would now go to the back to my my plugin configuration, and I would enable this rule, and I would go back to too many files opened to this one, you can now see that I have a rule violation that you know, transport object created by factory should be used. So you know, even if I do this to hack it, it's still no, like you cannot do this. So you know, maybe I need to just assign it to some variable and be done with it. Okay, so couple more stuff that I wanted to show you. So debugging. The rules are actually quite easy to debug if you set it up. So you know, now if I would go here and run my debug configuration, I also have the ESLint debug output enabled, so it neatly like says what it does on the go. I can now, you know, hit a breakpoint on top of my code base, and I can, you know, like do all of the stuff that you would expect. I can step over, you know, I can expand, I can see all of the AST nodes that I get here. I can traverse to parents, to child, stuff like that. There are also many helpers for this kind of stuff exposed by the TypeScript ESLint, I think typeutils package. So you can use that to, you know, make your life easier. So, you know, disadvantage of the TypeScript rules, they are a bit more expensive than the regular ones. So if I would run the lint with the timing, you know, I of course get all of the validations, and I also, you know, can see which rule consumed which amount of time. So you can see that the only like TypeScript or type-aware rule that I have takes much more time than the regular ESLint rules. And since you're, you know, maybe authoring some plugins that other people will use, and it should be reliable, you of course should write tests. So there's also a tooling provided for that by TypeScript ESLint. So you can create like this rule tester that will use the TypeScript parser, and here you will, you know, specify basically a chunk of code that will represent like a valid and invalid code, and you can run your rule on top of that. I mean, it's compatible with, for example, or like any test runner. So, oops. In my case, if I would just run like test via jest, yeah, I can see some, you know, some stuff being run and passing. But if I would, you know, go here and change the valid comment to something invalid and run the tests again, now I will get a test failure because like the rule was supposed to, you know, pass, and it is failing with some violation of the rule. Can I please ask what's the time? No one is tracking, so I can talk however long I want. Okay, cool. Apologies. If you're thirsty or hungry, let me know, and I'll cut it short. So, you know, some other rules that I have here, since we are going quite well. You know, I, for example, created this rule. Sorry?
Can you maybe show number 6, because I think you forgot to show the package organization.
Okay, yeah. Okay, so you know, I kind of intentionally did not go into the details of this rule because it's already a bit more complex. So I will make the repo available and you can look through it. I would even say that the implementation is a bit rough around the edges. So, you know, but yeah, it does work. So basically how it works is that you have some context, again, which is like specific for your file name. So in here, I basically, in the context, I get the config of the layers. I identify the layer from the path of that like file that I have, which is like the file I'm running on top of. And like this stuff that I have in the context that is then available in the like AST node visit functions itself. So then I have 2 nodes that I subscribe to. Is the program itself, where I can check like, okay, is the location of the file valid? Is the package name valid? And if it's, you know, if the layers are configured, is it in some known or unknown layer? And then I can also, or I also subscribe to the import declaration. And in here, I will like, you know, check, oh, okay, so it's some like relative import. So that's probably something we want to look at. So I will once again like identify the layer from the path of that file. And in here I can, you know, validate that it's the correct layering. Yeah, I mean, it's a bit lot to grasp just by looking at it right now. So again, if you're interested, the repo will be available. You can dig into it. You can easily run it on your own, make adjustments, play with it, do whatever you want. Okay, so let's quickly check the 2 remaining rules just to see what other stuff is possible. So 0.2, mandatory command. So imagine you have some class telemetry event that represents some like, you know, abstract data that you want to send somewhere into your telemetry, and you have a function that you use to send the data to some telemetry sync, to some, you know, Datadog or Amplitude or I don't know what, some product intelligence or telemetry application. And then you like, you know, extend the base telemetry event with some custom events. And, you know, maybe like you want to document these custom events. So when someone from product sees in your, you know, in your product intelligence application some event, they can understand where the event is actually triggered in your code, or, you know, what does it mean? What action was performed by the user? And me personally, I like to stick as much documentation in the code directly. So in this case, I would probably build a pipeline that would, you know, do the AST, traverse the AST, look for these like classes, export it somewhere, and then, you know, upload it into some like product intelligence event catalog where people could look and, you know, search for events and whatnot. So in this case, I want to enforce that this is actually documented. So, you know, I will enable this mandatory comment rule, and now I can see I have a violation that, you know, comments on telemetry event is mandatory. So I actually now have to go and I have to add something smart here. So if I would take a look how this rule is implemented, so it basically looks for class declaration that extends the telemetry event base class. And as you can see on this line, the like source code context can be used not only just to get, for example, all comments from the program, but you can also like use it to check if there's a comment before your node that you're like validating with your lint rule. And if it's not, you'll report a violation. Yeah. The last rule I kind of had prepared for the presentation is the no disabled test without to do. So let's see how it works. Right, so you have some test of some function, in this case some simple utility function that converts Pascal case from kebab, but maybe it's something more complex that has a bunch of side effects inside, and you don't mock some side effect, and your test is flaky. So you'll go into the file and you will you'll do this. So I mean, great, problem solved. Your pipeline is no longer failing, but this will be uncommented or removed never. So you can actually create a lint rule, no disabled test without to do. And oh yeah, this one I also wanted to show. So you can kind of subscribe to the AST node. You can also do a subscription via expression. So basically, this is not a subscription to just call expression, but it's a call expression that invokes a member skip on a object name describe. Right, so it's kind of like, you can of course do the same with the if statement, but this is kind of like a shortcut. So you can, specify multiple of those, and then you can check, okay, so does it have a to-do command before, which is some helper that checks the command above, same as before. So, now if I won't enable this rule, I immediately get a violation. Hey, you should have some to-do command here. So I'll fix this later. Well, no, right? We have the other rule that forces you to actually specify a proper command there. All right. So I think that's pretty much everything I wanted to talk about. I hope I didn't went terribly over or under a time. I will make sure to run the timer myself next time. Yeah. So, any questions?
There's one.
That was great, thank you. I have a question. Do you use any of these rules or any
Yes.
custom rules at?
Yes. Actually, some of the rules are inspired by what we use internally. Of course, a little bit simplified or adjusted. But yeah, we have, it's not hundreds of rules, but yeah, 40, 50 maybe rules that we use internally. We could do more. It's really then a question of whether it's worth the time investment to write the rule, or whether you can enforce the best practices or patterns in other ways, like pull request review.
And maybe a follow-up question, if I may.
Yeah.
What, in your opinion, is the most controversial or most discussed rule? From top of your mind, if there is.
Yeah, various alphabetical sorting of members of classes, objects, whatever, because you can always sort it, sometimes better, because it makes sense to sort it differently. I think also nested ternaries can be a controversial rule, myself, I don't like nested ternaries. I think they're usually hard to read, but in some cases they are actually better than to nest if-else statements. So, these kind of rules you really have to decide for yourself whether it makes sense. And you will probably make some trade-off in the end.
Thank you.
Any more question in the audience? In the meantime, you can still think of if you have a question. You don't have a question? No? Okay. I just wanted to say that you chose a really hot topic because our colleague Daria, she wrote a post how to write custom ESLint rules, and it's by far the most read blog post that we have. It makes half of our readership, and we wrote 200 blog posts. So hopefully it will get also as many views.
Yeah, I hope so.
So thank you, Milan.
Thank you.
And yeah, clap. Thank you everybody for coming. Thank you everybody for watching. And now some information for you. Unfortunately, not for you on the call. There is a terrace with a beautiful view, so I think we'll catch the sunset. So you can grab a drink, and I'll bring you up. And then, if you want to leave this building, you will not do it with the same door as you did, but you will have to go on the side, and you have to press a button to release yourself. So better go in 2, so you always can figure it out, better. All right, thank you very much for coming, and see you soon.